Hi, my name is Dina, and today I'm going to teach you about replication in a prokaryote. So let's take a look at a strand of DNA. Every strand of DNA has a lagging strand and a leading strand, which is based off the origin of replication and the 5' and 3' ends. The leading strand will have a continuous replication because it is going into the DNA versus the lagging strand, which has a discontinuous replication because it is going away from the DNA. This causes the formation of Okazaki fragments to form on the newly synthesized DNA. Now pause the video and see if you can place the terms in the right spot. So the top left and the bottom right strand is the leading strand because it's continuous replication, and the top right and bottom left strand is the lagging strand because of its discontinuous replication. Hopefully you got that right. Now let's take a look at the unwinding process the DNA goes through to separate its strands. At the origin of replication is where unwinding begins because of the initiator protein binds to it. Next, the helicase attaches to the replication fork and breaks the H bonds in DNA. In order for the DNA strands to stay apart and stabilize, it needs a certain type of protein. Pause the video now and see if you can figure it out. Hopefully you guessed single-stranded binding proteins. The last part of the unwinding process is the gyrase, which is placed in front of the replication fork to help with supercoiling in the DNA. The next step in the replication process is elongation. Since it cannot make DNA from scratch, it needs an RNA primer, also known as primase, which is an RNA polymers that aids in the addition of nucleotides. DNA polymerase III adds nucleotides to the primer. This primer is eventually replaced with DNA, and the Okazaki fragments are filled with the aid of DNA polymerase I. These gaps are also known as a nick and needed to be sealed in order to finish the elongation process. Pause the video and see if you can figure out the correct term. Hopefully you picked DNA ligase. Now that the newly DNA is complete, let's look at the chromosome as a whole. There is still a huge gap missing at the ends. Around 70 to 80 more nucleotides are missing. This is where telomerase comes in. It contains RNA, which it utilizes to make DNA and extend the end of the DNA. Once its job is done, it is eventually removed and the DNA continues through the transcription phase. These are my references.